Black holes are some of the most fascinating objects in the universe. And today we're going to talk about one that shouldn't exist. This black hole has no right existing at all, yet it does. It has been dubbed the unicorn, and I'll tell you why in just a moment. But first, let's start with a little backstory. Back in 2004, astronomers had a bit of a eureka moment. They were looking at a star cluster called M60 in the direction of the constellation of Serpens, and they saw something incredible. They found a stellar mass black hole, which is a black hole that has a mass similar to our sun, but with the size of a single city, orbiting a sun-like star. It was like finding a needle in a haystack, because while black holes can form from the remnants of massive stars, they're very difficult to detect. We know that when a star goes supernova, it can leave behind a neutron star or a black hole. However, this is usually only the case when the star is around 20 times more massive than our sun. And this one wasn't. Its mass was so low that it should have just left behind a neutron star, yet somehow it created a black hole. Now you might be wondering how scientists can tell the difference between a neutron star and a black hole. Well, it's simple. With a black hole, nothing gets out, not even light, whereas neutron stars do emit radiation. So the key to solving this mystery lay in understanding how this black hole was born. You see, astronomers had expected to find a large, bright blue star that had collapsed in on itself to create this black hole. But that's not what they found. Instead, it was a small, faint red dwarf.
Ow.
It was obvious that there was something strange going on here. A red dwarf shouldn't have enough mass to create such a large black hole. So either the star had gained mass from somewhere, or something else had happened. Scientists searched for answers and came up with several theories. One idea was that two small red dwarfs could have merged to make a bigger star, which eventually led to the formation of the black hole. Another possibility was that the star had eaten a bunch of rogue planets, or that it had accreted gas from its surroundings. None of these ideas really panned out. However, in 2019, a new study offered a potential solution. The researchers argued that the star was a helium star, meaning that it was born with only half the mass of our sun. Over time, it would have steadily accumulated material from its binary partner, slowly growing in mass. Eventually, it reached a critical threshold and collapsed into a black hole. So essentially, the star was a thief, stealing material from its neighbor, until it became too heavy to support itself. But how could they be so sure that this was what happened? Well, because of the unicorn's unique properties, it gave them a clue. You see, black holes don't just suck everything in, they also spit things out. As matter falls into a black hole, some of it gets flung outwards in the opposite direction. This creates an outflow of material that can extend thousands of light years from the black hole. And in the case of the unicorn, this outflow was full of iron. Now, you might be thinking, who cares? Iron is pretty abundant in the universe, right? Well, yes, but the amount of iron found in the unicorn's outflow was far more than expected. It was around 10 times higher than normal. And this gave scientists a big hint. See, iron is often produced in the cores of massive stars during supernova explosions. So the abundance of iron in the outflow suggested that the star that formed the unicorn had once been a massive star. And this made sense because a massive star would have enough mass to create the large black hole that was observed. So it looks like the mystery of the unicorn had finally been solved, right? Well, not quite. The problem was that this new theory still didn't explain why the star had become a red dwarf in the first place. Scientists had managed to figure out how the black hole formed, but not why. Fast forward to 2021, and another group of astronomers had an idea. They wondered if the unicorn had actually been born in a completely different part of the galaxy, and then migrated to its current location. If true, this would explain why it was there at all, because it would have formed from a red dwarf in the cluster. Now, this may seem like a pretty far-fetched idea, but bear with me, because they had some pretty compelling evidence. You see, the thing about black holes is that they don't just sit still. They move around. And in the case of the unicorn, it's moving incredibly fast. It's whipping around its host star at a speed of 30 million kilometers per hour. And that's not the only thing that's moving fast. The star itself is moving through space at an astonishing speed of 250 kilometers per second. To put that in perspective, that's equivalent to over 900,000 kilometers per hour. Now, the researchers couldn't explain why the black hole was moving so fast, but they did have an idea why the star was. You see, Stars move really fast when they're young. The reason for this is that stars are born in clusters. And these clusters are like giant cosmic nurseries, where stars form from giant clouds of gas and dust. Once a star forms, it stays in the cluster for a few million years, gathering speed as it goes. After that, it moves out into the galaxy and slows down. So the researchers argued that the speed of the star gave away its age, suggesting that it was relatively young. Now, if the star was indeed young, it wouldn't have formed from a red dwarf. In fact, it probably started off as a massive blue star. But then something must have happened that caused it to lose mass and cool down. And the researchers thought they knew what that was. It could have been a close encounter with another star that knocked it out of its path and caused it to lose a significant chunk of its mass. Now, you may be thinking that all of this sounds a bit crazy, and you'd be right. Astronomers were initially skeptical, because it was hard to imagine how a single event could both knock the star off course and cause it to lose so much mass. But in 2022, a team of researchers came up with a possible mechanism. They suggested that the star had encountered a cloud of gas, and this encounter had removed its outer hydrogen envelope, leaving behind a helium-rich core. This would explain why the star was so faint, because it was now much smaller and cooler. It would also explain why there was so much iron in the outflow, because the missing hydrogen would have been replaced by heavier elements that were forged in the star's core. Essentially, this last-minute transformation turned a massive star into a small one, creating the black hole that shouldn't exist. However, the researchers acknowledged that this was still a tentative hypothesis. They needed more data to confirm it. And this brings us to today, because in a new study, astronomers have presented more evidence in favor of this model. They used a powerful instrument on the ALMA radio telescope in Chile to take a closer look at the gas surrounding the black hole, and what they found was surprising. The gas was moving faster than expected. In fact, it was moving at the same speed as the star itself. This suggests that the gas was indeed stripped away from the star, forming a dense shell-like structure around it. And this is exactly what you'd expect if the star had experienced a close encounter with another object. So overall, it's looking increasingly likely that the unicorn was born from a massive blue star that lost its outer layers, revealing a small helium-rich core. This is a rare phenomenon that has never been observed before, at least not in our galaxy. So it's really exciting stuff. It's amazing to think that something so bizarre could exist so close to us. Now, it's a reminder that there's still so much we don't understand about the universe. The research has been published in the Astrophysical Journal. If you want to read it for yourself, you can find the paper online. If you enjoyed this video, please subscribe. And as always, thank you for watching.